Yes, that's an inscribed angle right there. So we're going to use clockwise convention for naming. And thus the inscribed angle would be B to A to C, BAC, angle BAC. And the intercepted arc would be the arc going from B to C clockwise. That is not an inscribed angle. That is not an inscribed angle. That is an inscribed angle. Named well, if we do it that way, I guess VXW and intercepted arc would be VW. That's a central angle, so no. And we'll check as we go. Okay, so they've named it similarly. All right, that's good. They've called it the measure of angle BAC, which is not right. All right, so they've called it WXV. I guess that follows their clockwise convention. Just go clockwise around the circle, like that. And the arc is, the intercepted arc is WV. Now find the measure of the arc or angle indicated. Okay, so by the, what's it called again? The inscribed angle theorem, I believe. Let's see. Okay, yeah. The inscribed angle theorem states that this angle here is double this angle here. The angle at the circumference is twice, the angle in the center is twice the angle at the circumference. So in other words, this should be 40 degrees. And we need to find the measure of that arc right there. This will be 90 degrees, as the angle within a semicircle is 90 degrees, of the two chords joined to the diameter there. So that'll be 48 degrees. There's I don't know what they mean. I don't know what they mean. Measure of the arc, 1. All right, so perhaps they mean something like this. Like that. And that'll be isosceles, and that'll be 48. And that there will be 180 take 96, which is 84 degrees. Now find this angle here. All right, so that's 35 degrees. That's 35 degrees. These are using circle theorems. Isosceles triangle is 35 degrees. 180 take 70 is 110. Okay, now to find this angle here. Forty-nine at 70 is 119. So we get 61. Yeah, so that'll be half of that one, huh? So it'll be 30.5. No, it'll be double it, actually. Beg your pardon, so that'll be 122 degrees. Right, so we'll check for all of these. 40, 84, 110, 122. All right, that's fine. Circular quadrilateral. The opposing angles in a circular quadrilateral add up to 180. So 180 take 65 is 115. And then 180 take 119 is 61. And they say that's 168. Now there is 168 apparently. And now we need to find that. All right. Why were we given all this extra information? Does that actually even help us? Or is it just a distraction? I don't know. Guess I don't see it. I mean, of course, genuinely don't know for that one. Okay, so that's... I guess I don't really know how to do these. Well, it's time for me to learn. So, the one on the left is 60, but how do you know? How do you know? Okay. All right, offset angles that up to 180. How does that help, though? Okay. I have no idea. Sorry, I just don't know. Just don't know. Don't know. That's fine. I'll give it my best shot for these ones. Can't expect to be able to do everything. Maybe I'll come back to these as well. That's another possibility. Find the measure of NLM. So in other words, this here. Okay, so that is 13x take 10. (180). Take away that, and then divide that by 2. That's one possibility. The other possibility, that's 7x take 10 and isosceles. Well, we'll just try. So that's 7x take 10. And then divide that by 2 and you'll get that angle there. And then do 90 minus that, and then you get that angle there. So these expressions are obviously hideous. So somehow find a way to clean them up. So 180 plus 10, so that's 190 divided by 2, that's 95. So 95, take 13 over 2x. Okay. And then on the top, and then on the bottom rather, 180 plus 10 is 190, divided by 2, 95, 95. 90 take 95 is minus 5. Plus 7x would have to equal that. So 100 on the right. And then 13.5 on the left. Or 27 over 2. I mean, this is just crazy. There's no way that this is the answer. Okay, so what, x is 200 over 27? And then you have to find NLM. So what, I pick up that and now I'm putting it. Come on, this is ludicrous. Well, we'll try. We'll try. All right. So we're going to do minus 5 plus 7 times, and then 200 over 27. So we get that, which is about 46.86. And now we're going to see. Yes, this is just absolutely ridiculous. Like, there's no, I genuinely don't understand like any of this stuff. Guess I'll have to come back to it. Oh well. Gonna do the next one. I guess not. Do you know what? I'm kind of geometried out right now. Am I? We must try. No matter what, we must try. So do it. Determine if line AB is tangent to the circle. So the way that we're going to do that is we're going to put a question mark here. And if it's tangent to the circle, that would be 90 degrees. And if it's 90 degrees, then 12 squared plus 20 squared would have to equal, 12 squared plus 16 squared would have to equal 20 squared. And does it? Does 144 plus 256 equal 400? Yes. So it is. Next. Likewise, this would have to be a right angle, and we don't know if that's true. And so just simply ask, is 6.6 squared plus 11 squared equal to 13 squared? But it isn't. So no. 6.6 squared is 43.56, and 11 squared is 121. And when you add them together, you do not get 169, but you get something close. Likewise here, 12 squared would have to equal 20 squared. And we just established that fact, literally, just then. And finally, if so, then 11.4 squared plus 15.2 squared would have to equal 19 squared. 11.4 squared $129.96. 15.2 squared $231.04. And does that equal 361? Yes. So it is. And all right, so we have agreement. Find the segment length indicated. Right, so that's the diameter. Assume that lines which appear to be tangent are in fact tangent. That's the diameter. So this is just an application of the Pythagorean theorem. So square root 7.5. Oh no, I could have done that myself. Darn it. Okay. So I'll just do square root of 2.5 squared minus 1.5 squared. So that's 6.25 there, 2.25 there. Subtract them and you get 4, and you square root that and you get 2. This is the 12, 16, 20 triangle that we just saw. Now for this one, here they're just giving you the radius for the diameter. That would also be 6. So it's going to be the square root of 12 squared plus 6.4 squared. 12 squared is 144. 6.4 squared is 40.96. 144 plus 40.96 is 184.96. And is that a perfect square? Is that a perfect square? Okay, so let's try some stuff. So 16 is 2. Beg your pardon. 13. What about 13.6? What about that? All right, so we square that. Well, 14 squared would be 196, so that's way too high. So 13.6 squared. It should work, shouldn't it? 13.6 squared. No, it's not. perfect square, is it? And you see here, it is. What's going on here? No, check it yourself. 13.6 squared. So we get 169 plus 13 makes 182. Now plus 36 makes 185.6, and plus that extra, we see it is. Just have to push and check. Push and check. Find the perimeter of each polygon, assuming that the lines which appear to be tangent are tangent. All right. Okay, so 10.5 at 11.2 is 21.7. Oh, I know. These are equal in length. Of course they are. That's 10.5. And this divided by 2 should be 11.6. So that's 11.6. So now add everything together. So 23.2 plus 22.1 is 45.3. 45.3 plus 21.7 is 67. Okay. So that small segment there will be 4.6. 21.8, half that, we get 10.9. So that small segment there will be 10.9. And then we need only add up everything that we can see. So we'll proceed. We'll gather up the smaller decimals first. So 9.2 plus 10.9 is 20.1. 20.1 plus 21.8 is 41.9. And then 41.9 plus 38 is 79.9. Or so it seems. Next up, that'll be 14. 22.7 divided, that's not quite right. That is not quite right. Don't just divide that by 2, that's wrong. Okay, so 23 minus 14 is 9. So that's 9, that little bit right there. Likewise, that little bit right there is 9. And then 22.7 minus 9 is 13.7. And so this part here must be 13.7. And so we add that, and that. Let's go. So 13.7 doubled is 27.4. 14 doubled is 28. 9 doubled is 18. So 18 plus 28, that's 46. And then add 27.4. So that's 73.4. Or so it seems. This small segment is 5.4. 20.5 has to be divided by 2 to get 10.25. And 10.25 there. No, it doesn't. That is totally wrong. Sorry, it's totally wrong. Instead, what must be done is 18.4 minus 5.4 to get 13. And then that is 13 right there. And then 21.9 minus 13 to get 8.9. And that too is 8.9. And then 20.5 minus 8.9. So just do 20.5 minus 9 and then add 0.1. So we get 11.6. And that too is 11.6. And then add up every red circled quantity. So 10.8 plus 23.2 makes 34. And then 34 plus 17.8 will result in 51.8. And then 51.8 plus 26 results in 77.8. Or so it seems. Now find the angle measure indicated. Assume that lines which appear to be tangent are tangent. Okay, so that'll be 90 degrees. But if that's 63 degrees there, and this is an isosceles right triangle, that'd be 63 degrees there on the other side. And these complement each other. So 90 take 63 is 27. And this is oh darn, I just lost it. Oh well. Well, what do I do? I don't know. Oh, I know. That's a straight line. Of course it is. So 180 minus 63, which is 117. And then 117 plus 27 makes 144. Take that from 180, and we have 36 degrees. Next up, we've got a 90-degree angle there. And down in the corner, complementing this 44 degrees, will be 46 degrees. These are isosceles. So that's 46 degrees. And finally, 46 degrees doubled is 92. Take that from 180, and we get 88 degrees. Here, the angle is half, is it not? Is it not exactly half? So half of 117, which is 58.5 degrees. Now here, that's a 90-degree angle. That angle down there, complementing that 52, must be 38 degrees. This is isosceles, as these are two radii, so that is 38 degrees. 38 doubled is 76, subtracted from 180 is 104, so that's 104 degrees. And now I check everything. Okay, so that's accurate. That's all correct. Oh man, that should be... Oh, goodness me. Only the last two are right. Okay. We're going to get these right. We're not going to mess around. We're going to get them right. Okay. So, 23.2 divided by 2 is 11.6. Then that over there is 10.5. And 23.2 minus 11.6 is... it's 11.6, is it not? Oh no, that's not right. Can't you see? That would be 11.2. Okay, now take that from 23.2 to get 12. And that should be 12. And now find the sum of these 6 circled quantities. So we get 21, 24, sums to 45, 22.4, 45 at 20, 45 at 22.4 is 67.4. And we check, and that's correct. Now, over here, that is 4.6. Whereas isn't there anything that we can work out here? Oh yes, that there is 13. And therefore that there is 12. And that there must be 12. And then 21.8 minus 12 is 9.8. And that there is 9.8. And now we circle 8 quantities which occur in 4 natural pairs. And we must find the sum of the pairs. So 26 at 24 makes 50. 9.8 doubled is 19.6. 4.6 doubled is 9.2. 19.6 at 9.2 is 28.8. And add that on to 50 and you get 78.8. And that's correct, and that's good. So 36, 88, 58 point... That's not right. Okay, that's 104. Okay, so why is this not right? 58.5. Put that in the trash bin, which is over there. It is over there. Got to figure this out. Okay, well, this is a kite. So that's X. And that's X as well. And X, isn't it the case that X at X is 180? Because they're tangential, aren't they? And then 100, so the question mark angle and 117 degrees have to supplement one another, and therefore this should be 63 degrees. And we check, and that's correct, and that's good. Okay, fair enough. Okay, it's not so easy for us anymore. more right now. We'll still try though. Find the measure of the arc or angle indicated. All right, how many of these we've got to do? 18. No, I'm probably going to be less talkative right now. Right, so that's 170 degrees. I don't even know. What is this 50 degrees pointing to? What is it pointing to? Is it that angle there? Seems so, but who knows? Who knows? They're just going to have these crazy conventions which don't make sense. You know, who knows? Maybe 50 degrees refers to this angle here, right? Just don't know. So I'm going to sort of move a little bit past that. I'll put it in gray, and it must be returned to someday. But you know, I don't have to contend with poorly labeled stuff. But also, you know, I should be smart enough to figure this out, really. But it is what it is. Be well, be well.